Hey math kids, today we're going to talk about shape, and so the two concepts we need to talk about, concave down, maybe. Okay, so if we have a function that looks like this, the portion up to this point is considered concave down, and then the portion from here to the rest of it is concave up. Okay, and so when we're doing this, to find this point of inflection, so to find that point of inflection, we take the second derivative. And concave down on like a sign diagram of our second derivative will give us a negative point, and concave up will give us a negative region or a positive region. Okay, so let's just try a couple examples. So we're given 2x squared or cubed minus 3x squared plus 4x minus 6, and we need to find the point of inflection. So it says find the intervals where the curve is concave up or concave down. So to do that, we need to find the point of inflection. So if we call this f of x, we find the first derivative, and we get 6x squared minus 6x plus 4. And then we find the second derivative by taking the derivative of f prime. We end up with 12x minus 6. Now we want to set that equal to 0, and just solve. So we add 6, 6 equals 12x, divide by 12, and so x equals 1/2. Okay, so we have a point of inflection at x equals 1/2. We mark that. We choose values on both sides, so I'm going to choose 0 and 1. And now if we plug those into our second derivative, we just want to know if we get a positive or a negative value. If we plug in 0, this will go away, and we're left with negative 6, so that is just negative. Now if we plug in a 1, we get 12 minus 6, which is a positive value, and so we get these. Now remember, this is the second derivative, so this tells us about concavity. And so what we're going to have first is that if x is less than 1/2, or less than or equal to 1/2, we're going to be concave down. And if x is greater than or equal to 1/2, we're going to be concave up. Okay, and let's do one more like this. So we have x plus 1 over x minus 3. And we need to take the second derivative. So we need to go through the quotient rule. And so once again, I'm going to flip back to the quotient rule, and we take the derivative of the top, which is just 1. And then we times that by the bottom. We subtract that from the top, times by the derivative of the bottom. And then everything is over x minus 3 quantity squared. Okay, so once again, this is like our y prime if we consider this our y. So if I simplify that, I get x minus 3, then I'm distributing this because this 1 doesn't matter, minus x minus 1. These x's cancel. We're left with negative 4 over x minus 3 quantity squared. Once again, this is just our first derivative. Now, we're asked to find the second, or we need to find the second derivative. So I'm going to rewrite my y prime as negative 4 x minus 3 to the negative 2. Now when we take this derivative, we bring this down, we end up with an 8. Rewrite the inside, drop this by 1, and then we need to multiply by the derivative of the inside, which is just 1. So we can actually just look at it like that. That's our second derivative. Okay, now that we have the second derivative, we set this equal to 0. And so what we need to look at, I guess, first is I'm going to rewrite that as 8 over x minus 3 quantity cubed. And so there's no place that we have a root, because if we were to set this equal to 0, for example, and we multiplied both sides by the bottom, these would cancel, this would times by 0, and we get a statement that's 0 is equal to 8. That's not true, and so we don't use that. Now, there is division by 0 possible, though. So if we plugged in a 3 for x, there's division by 0. And so what happens is we look at an asymptote right there. So we want to check out maybe 0 and 4. And if I plug in 0, that's going to be a negative value. And if we cube a negative value, it's still negative. And then we have a positive value on top. Positive divided by negative is still negative. And then if we plug in a 4, that's going to be a positive. Cube a positive, it's still positive. Positive divided by positive is positive. And so this is our thing we got going on. And now if we do x is greater than 3, that's going to tell us concave up, because that's positive. And then if we do x is less than 3, we get negative, and so we say down. Okay, if you need additional help, please come to Math Lab. Until then, calculator.